Hello everyone and welcome to today's session on computer basics. So we'll start with what is a computer. A computer is an electronic device that takes input, processes the input and gives an output. So what do we mean by electronic device? Any device that works on electricity and has electrical components or electrical circuits are called as electronic device. Takes input. That means it will take an input which could be touch, typing, or it could be voice. It processes it. Processes in the sense that it will take the input and it will manipulate it or calculate whatever the task requires. And once it manipulates, it will give that answer or the solution, which is called the output, onto the screen. So output would be displayed on your output device. It operates through IPOS. I stands for input, P for processing, O for output and S for storage, using hardware and software. Hardware are the physical components of the computer and software are instructions or programs. Now for example, you enter marks such as 75, 80, 90. So this is basically the data which you have entered using your keyboard onto the computer. Computer calculates the sum. This is processing. Processing is done by the CPU. The results, which is the calculated sum, the total marks, this is the final solution and this is the information which is displayed on your screen, the output device. Okay, so basically the same thing is done on the Excel, what you would do on your computer, you will open the Excel sheet, which is again an application, which is a software on your computer. You would ask the computer to sum up, say for example 70, 80, 90. Once you do enter, in the blink of an eye, it will give you the solution 240. So what you did here was, you gave the input, 70, 80, 90 is the input data that you have given to the computer. Once the sum is the operation that you want the computer to do it, it understands that, it goes to the CPU, calculates and gives you the output in the blink of the eye. So output can be seen on your screen here, 240. Okay. So now one of my student would say, oh teacher, what is this? Even I can do this in the blink of an eye, 70, 80, 90, 7 to the 14, 15 plus 90 to 40. That's it. But what the main important thing to understand here is, if I give the computer big numbers like the one as shown on the screen and ask it to calculate it, again it will give me an answer in the blink of the eye. So basically, computer moves across the human limitations. What humans cannot calculate in minutes, the computer does it for us. So it eases most of our work. Okay. So now, moving on to the next screen, are these computers? Why or why not? So smartphone, nowadays even kids or almost everyone has smartphones in their hands, right? So is smartphone a computer? Tablet, is it a computer? Laptop, is it a computer? Desktop, is it a computer? Alexa, we know, right? A smart speaker, Alexa, is it a computer? So one of my students gets up and says, okay, smartphone, fine, tablet, I'll take it, laptop, desktop, all these can be computers. But Alexa, how is it a computer? So let's understand. So basically, by definition, we said computers are electronic devices, correct? So it needs electricity. All these work on electricity. So maybe mobile phones, they don't need to be continuously connected to your electric supply, but inside them they have electrical batteries. They have batteries basically that provides the electric supply that is needed. Similarly for the tablet, laptop, desktop, yes, we need to connect it to the electrical supply, and even Alexa. Okay, now next part in the definition is that Computers take input, process them and give an output. So in this screen, if you see, I have elaborated each device, what is the input it takes, what process, how it processes an output. If you see a smartphone, it will take input as touch and voice. It will process, runs or calculates, and it will give an output which is on the screen or this display that is provided to us. It can even be sound because we can play music also on mobile phones, right? So it is a small computer. Tablets, similarly, tablets also input, touch, processes, runs, apps, calculates. Output we can see on the screen, sound. Works like a smartphone but bigger. The size is bigger, okay? Also a computer. Next, the laptop. Yes, basically, keyboard is provided, mouse, and even you can have pen drives, external. There are many external components you can attach as inputs. And then process, it can do complex work like documents, even coding. Coding is what we'll be looking into it when we deal with languages, software, everything. So I'll go deeper into coding. Right now you can take it as, yes, it is a complex task that the computer, this laptop performs, okay? The output, it has screens. It can also be a speaker or it can be connected to a printer. So output can be screen, speaker or printer. So this laptop is a full computer. Desktop again, input can be keyboard or mouse. Process, again here, does complex work like documents, coding, gaming, designing, etc. Output, screen, speaker, printer, etc. The powerful computer. Okay, the configuration can be very high. Alexa. Now here is where my student pointed out that how can this be a computer? So here if we see input is your voice. Process, when you give command to Alexa, it's an input that is going inside. Process, it understands your command. And output is speaks, it answers, plays music, whatever. It gives an output in the voice form. So this is a special computer. So we can say that all of these devices do IPO, which is input, process, output, storage. Hence, we can say they all are computers in their own way, just in different forms. Okay. Now moving on to, we have actually understood this concept till output part. Now we'll work with it. This IPOS operates using hardware and software. Now, what is hardware and software? So this is basics of computer system. Hardware are all the physical parts of the computer you can touch. For example, if you see here, this is the monitor, the keyboard, mouse, and this box. So it's a black box for us because we don't know what exactly lies inside. But all these parts and much more complicated parts are stored inside this. Okay. So we'll see this in the next slide. I have incorporated that so that you understand this black box. But this is the CPU for now. You can take it that way. So all the physical parts of the computer you can touch are hardware. Okay, so here you have monitor, you have keyboard, mouse, CPU, memory. Memory can be of two forms, RAM and SSD. I have also covered in the next few slides about RAM and SSD, difference between them. Printer, so all this is hardware. Now what is software? Softwares are the programs and operating systems or even drivers basically that tell the hardware what to do. So here if you go on your computer on the start menu option, you will see all the programs that you have installed on your computer. Every computer has an operating system. That's the base software that is needed for the computer to run. So basically all the application programs, apps, programs that help you do different tasks on the computer phone. Games, Paint, YouTube, calculators, all this is software. Device drivers What do you understand by that? Software that helps the operating system communicate with the hardware device. So your hardware device, for example, printer, it will have a printer driver, graphic driver. So for every hardware component, you might have a device driver. Operating system, softwares that manage computer hardware and software and allows users to interact with the computer and tell the hardware what to do. Examples are operating systems, Windows, Linux, Android. So when you tap on a game on your screen, the operating system opens it so you can play. Okay. So now moving on to the next slide, which is difference between RAM and SSD. Full form of RAM is random access memory and SSD is solid state drive. RAM is a temporary memory. So as soon as the power is off, whatever data is in that memory, it will be lost. Okay. So data retention is temporary. In solid state drive, it retains the data even when the power is off. Speed of RAM is very fast, nanoseconds. SSD also is fast, microseconds, but slower than RAM. Now RAM it holds data currently in use by CPU. So whatever CPU needs, quickly if you need to access, this RAM is used. RAM uses that. Now for example, the example that we had taken 70, 80, 90 and the operation was sum. So this whole thing, the RAM was holding all this information which the CPU quickly accepted from the or accessed it basically from random access memory, calculated the sum and threw it to the output. SSD stores files. So once I had completed my Excel and I go to the save button and click save, that what it does, it saves the Excel file onto your storage file system. Okay, so it's a final destination where it retains even when the power is off. So once you just switch off and go back, do certain work, come back, and again if you switch on the computer and open that file, you will still have your data there. Okay. Now RAM example is it can be 8 GB DDR4 RAM. DDR stands for double data rate. So DDR is a type of RAM technology, DDR. And for SSD, non-volatile memory express, this is a technology protocol used by SSDs. Okay. So moving on to hardware and software. So our base would always be input, process, output cycle. So how each of this, here on the screen I have shown how each of this performs with the input cycle, the IPO cycle, that is input, process, output cycle on all these different devices. So if you see smartphone, the hardware for the input can be touch screen, microphone, buttons, sensors. The software would be touchscreen driver, voice recognition apps and keyboard apps. Hardware basically for the process would be CPU, RAM, internal storage, GPUs. Software would be operating system. Now here you need to note that for smartphones you have a different operating system, Android, iOS. If you look at laptops and desktops, they would have operating systems like Windows, Mac, OS, Linux, etc. Okay, so they can perform the performance. There are basically many differences that we will dive deeper in later sessions basically. So here, since this is covering the basic, we'll just touch on to these topics. Okay. So as you can see on the screen, the outputs here are almost very similar like hardwares are display, screen, speaker. For smartphone, for tablets it would be display, speaker, vibration, motors. Laptops would be display, speaker, headphones, LED indicators. Desktop, monitor, speakers, headphones, printers. So and here for Alexa, the software would be text to speech. So if we go on to later text to speech, even later we'll have sessions on NLP, natural language processing, wherein we'll dive deeper and understand how the text to speech conversion or text to speech to text conversions takes place. Okay, that again would be a different session altogether. Moving on to the next slide here, Aryan opened a software application on his computer, entered 2 plus 3 and saved the results. So already I have explained this earlier. This is just a revision for you all to understand that IPOS, how the IPOS cycle along with the hardware and software to complete this task. Basically, we have seen input where from the keyboard I had entered 2 plus 3, then processing, the CPU did the processing, output was shown on the monitor, and storage, once I saved the file, it got saved on the file system. Okay, now I had told you the CPU is a black box. So what exactly goes on inside and how it goes on? So if you see here, this was the black box that was shown there, right? Now here if you see, this is the whole motherboard on which you have sockets wherein you can connect your device, input devices like your keyboard, your mouse, etc. Here you have a socket and this arrow shows that there is connectivity with the output device. You have a CPU here, processor, the brain of the computer. It fetches instruction, processes data and controls all the parts. These are the slots for RAM memory, temporary memory. We have seen this, right? RAM, random access memory. This stores data and instructions that the CPU is currently using. 2 plus 3, number 2, number 3 and the operation addition. So it has stored that, and data is lost when the power is off. SSD, permanent storage. Once the Excel file was saved, our file and data, everything is saved here. So even after shutdown, you retain the data. This is the chipset, acts as a controller hub, manages communication between CPU, RAM, storage and other devices. Now, for all this communication to take place, buses and pathways. Data travels through buses. So all the data that is there between each of these components, you need a pathway, which is an electrical pathway on this motherboard, and they are called buses. Okay, so here entering data, typing on the computer, clicking a mouse, speaking in a mic. All this was input. Processes, manipulates the data. So the black box is now clear, right? So you're aware what happens inside as well. Now we have clearly understood the IPOS cycle, which is the base for computers. So now we will just look at the evolution of computers. So where have we come from, and as of now, present, where exactly we are? So early history, it was ABACUS and analytical engines. Now if you see ABACUS, early calculators used by ancient civilizations. 1830s, Charles Babbage designed the analytical engine, the first conceptual computer. So this laid a foundation of calculations and ideas of programmable machines. Like machines can be programmed to do the work that humans were doing. Then came the first generation, 1940s, 1950s. These were the vacuum tubes. Now this is the photo of a vacuum tube, punch card as input and output. So used vacuum tubes for circuitry. These were actually massive in size, consumed lot of power and produced lot of heat. So used, and these were not accessible to normal people, public. These were very few because obviously look at the size. And they used punching cards for input and output. So these were only for the privileged few. Built the first electronic computers capable of solving complex calculations. These used to solve complex calculation. Next, second generation, 1950s, 60s, they came up with transistors. So transistor replaced the vacuum tubes. The transistors were smaller, faster, more reliable and energy efficient. If you see here, and a lot of energy was needed and heat was produced. These were energy efficient. So these used magnetic core memory and magnetic tapes. examples IBM 1401, etc., made computers more reliable, affordable, and practical for business and scientific uses. Next came the third generation, 1960s, 90s, 70s, wherein integrated circuits, silicon chips were used, ICs. They were even smaller, more faster, and more efficient. These supported operating systems and multitasking. Multitasking basically means multiple executing of multiple tasks within the same time duration. So if you take, for example, your mother would be doing multiple activities within the same time limit. For example, she might start her cooking, and while she has chopped and cut, and the oil is still heating, she'll go and wash the utensils, whatever were removed, and leave them. Then again, as soon as she puts the onions in the oil, she'll go and start on the your washing machine. So basically, during the gaps that she receives, she does certain other activities. And within the same half an hour, she would have completed 3 activities, 3 tasks. So that is called multitasking. Examples here are IBM System 360 PDP-8. Enabled software development. So during this generation, software development was enabled. Operating systems and multitasking capabilities emerged. Fourth generation, 1970s and present. So here we see microprocessors. Microprocessors place thousands of ICs on one chip. And this led to personal computer revolution. So now if you see, in every house there are computers. Smaller, cheaper, powerful, and widely used. Everyone has them. Even normal public, middle class people. So these brought computers to homes and office, changing the world forever. And now coming to the present and future. So now we are moving on to AI, parallel processing, and quantum computing, which we now aim to create intelligent machines, solving complex problems and transform our future. So from today to tomorrow, the future of IPOS. So basically, if you see from right from the earlier ancient times till today, IPOS has not changed. That is the base of computer: input, processing, output, storage. So what do we see in the future? So basically we can say the future is now here, because we can see nowadays in cities there are certain devices that you see being used. We can see in the input devices as gesture control. So your hands and body gestures captured by motion sensors and cameras. For example, just by a tap of your hand or clap of your hand, you can switch on your lights in the house. And this you can do it, you can actually have control over all these activities right from some other location also. Nowadays it is possible, but for the privileged few. But maybe in days to come, this would again be accessible to almost everyone at very minimal costs. Next is brain-computer interface. So there would be a connection between brain and computer interface. The brain it would be able to read brain signals to control devices using your thoughts. Eye tracking, so wherever you're watching, it would detect the eye movement and gaze to interact with systems, and you would be able to interact with them. Holographic touch panels, wearable sensors, so there would be smart rings, bands, or suits that capture movement, vitals, and commands. So this is already there, right? Nowadays you can see that it captures your heartbeat, everything, and then it is stored on the clouds, wherein the data is processed and your health and activities, everything is monitored. So your doctor gets your real-time reports, right? Advanced voice inputs, understands natural speech in multiple languages and accent. This is also there right now. So you can actually, there are no barriers now. Or you can speak in your language and it would be translated in the native language wherever you are going out there in the world, and they would be able to understand what exactly you are speaking. Now, futuristic processing units, quantum processors, neuromorphic chips, 3D stacked memory, cloud, edge computing, all this is currently, this whole thing has started, right? AI, machine learning engine. So in later sessions, we'll be delving deeper into AI, machine learning, data science, and NLPs. Now, futuristic output. So holographic displays, this is also there nowadays. For presentations, they use holographic displays, projects 3D images in the air without any screen, so that we can understand the futuristic projects that we are trying to plan. AR, VR headsets, these are also available, but not to at a very lower cost. Displays immersive, augment, and virtual experiences. So augment reality, virtual reality, flexible rollable displays, haptic feedback devices provides touch, vibration, and force feedback to feel virtual objects, projection mapping, etc. Smart contact lenses. This will display information directly on your eye. So we have seen here how it works. Input devices captures data, action or command, processing data using advanced hardware software. Output devices shows results, visual, sound, or feedback. So basically computers have come a long way. The input devices have changed, they have become smarter, and now we're moving on into the consciousness and intelligence of computers that would mimic human intelligence and consciousness. So futuristic computers will understand us better, think faster, and show results in more natural and immersive way. So if you see now, you can actually communicate with ChatGPT. It understands and you better when you're giving inputs, and it will give you an output also in a human interactive way, right? Now, impacts of technology. So, how technology helps mankind? It makes learning easier, connects people worldwide. Today, everyone is connected to each other. We can see how people worldwide, their culture, everything, understand better. Computer is important. It has drastically changed all the industry. Basically, every industry has been touched by the computers. It helps in every industry. It helps in some way or the other. In space research also, because of the computers and the computation power, we are doing very well. So without computers, even this video wouldn't have existed, correct? Now, cons of the technology, especially as I see for kids. Too much of screen time, less physical activity, distraction from studies, addiction to games, social media. Let's be honest here. Sometimes 5 minutes becomes 2 hours, isn't it? So, my final message to the students: technology is like a superpower for you. But remember, use it to learn, not just scroll. Use it to create, not just watch. Use it to grow, not waste time. Because the future of technology is actually you. So here I have completed my session for today. Thankfully, gratefully blessed. Goodbye and have a blessed day ahead. Alvida, Nirop, Annyeong, and Sayonara. Khuda Hafiz. Stay curious, keep learning, and I'll see you in my next video. Bye for now. Thank you for joining.